Hey, so in this video, I'd like to go over the answers to the atomic trends worksheet. All right, this worksheet is broken up into a couple different sections where you're trying to predict different trends. The first trend that we're going to talk about is size. All right, and another way to say that is which atom has a larger or smaller radius. All right, so remember that the trends for neutral atoms is to say that the further left you go on the periodic table, the bigger it gets. But also the further down a group you go, the bigger the radius gets. All right. One quick way to remember that is to just remember that cesium, which is down here, in the lower left, would be the largest naturally occurring neutral element. All right. Another thing that you might be required to know is that when that a positive ion, all right, is smaller than its corresponding neutral atom, whereas a negative ion is larger than its corresponding neutral element. All right. So to do this, you're going to want to have a periodic table close by. All right. Remember, you're allowed to use the one that's in the reference guide. I'm going to use a different version that puts all of these on the same page, so that's a little bit easier. All right. So in the first case, we're going to compare calcium and nickel. So again, notice that both of these are neutral. All right, so we're comparing apples to apples here. All right, so calcium versus nickel. All right, the first thing that should stand out is that they're in the same period, but calcium is further to the left. All right, so remember, as you go to the left, things get larger. That would mean that calcium would be the larger atom. And then next one, comparing calcium to barium. Okay. Calcium is right here, barium is right here, and the trend that you're going to want to recognize here is the one which involves going down a group. All right, barium is lower, so that would be considered larger. Notice that this one right here, it compares just different, the same element but with different charges. All right, so this is the one where you're going to use the trend of like comparing a neutral atom to a charged version. All right, and when you compare a neutral to the positively charged, all right, remember it gets smaller when you make the positively charged one. A really quick way to remember both of these is just to remember that the more negative thing is always larger. All right, so comparing neutral to positive, the neutral thing is more negative, therefore that would be considered to be the larger one. All right, the next one down actually asks you to compare two different things. And the best way, the way I think makes sense to do this is to first do a comparison of the two neutral atoms. All right, so let's say that we were comparing rubidium to iodine. And if we compare those two neutral atoms, you can see that they are both on the same, in the same period. So iodine right here is the, by comparison between the neutral atoms, iodine would be the smaller of those. So if we were to compare head-to-head between the neutral atoms, the iodine would be the smaller. But when we go from the neutral iodine to the negatively charged iodine, that would be a trend that makes that atom larger. All right. So in this case, we can't tell the difference because in going from rubidium to iodine, that would be a trend in getting smaller, but then in going to the negative ion, that would be a trend in making it larger. So based on that, we can't tell. It would depend on how much larger and how much smaller here. So in this case, we would just say can't tell. All right. This one we should be, let's take a look. This is comparing to neutral atoms. And notice that both of these elements are in the same group, so we should be able to tell just by saying which one is lower. All right, so calcium is lower on the periodic table, so that would be the larger. All right, here we're comparing two neutral elements. And notice that these two are not only on different periods, they're in different groups. All right, but you can still use a little bit of logic to figure out which would be larger. Remember, the further to the lower left corner, the larger it would get. All right, so the way that you could think about this is in going to the left here, things would get larger, and then in going down here, things would get even larger. So we can definitely make the conclusion that this atom right here this neutral atom would be larger than this neutral atom. So notice that in this one, we're comparing two different things. First of all is the identity of the element, and one is in a charged version and the other one is neutral. All right, but we might still be able to figure this out. All right, and again, what you want to do first, if it was a question like this, is to say, let's compare the neutral versions of these. All right, so neutral calcium versus neutral rubidium. In looking at these two right here, rubidium is closer to the bottom left, so rubidium would be the larger of these neutral elements. So if I were just to be comparing these two atoms right here, calcium would be the smaller of those two. All right, but then if you take neutral calcium and you turn it into the calcium +2 ion, all right, remember the neutral version is going to be larger than the positive version. All right, so the more negative, the larger it is. So it would get even smaller in going this way. So if we compared this to this, we could definitely say that the rubidium would be larger. All right, because the trend would be gets smaller going from here to here, and then this would get smaller and going from there to there. Okay, for some reason, this one was right here was repeated, so we can skip that one. All right, in this case right here, we are comparing the neutral bromine to a negative bromine right here. So the negative version is going to be larger. All right, so again, that is using this trend right here. All right, here again, the way to do this is to compare the two neutral versions first. All right, so if you compare these two right here, sulfur is lower on the periodic table than oxygen, so that would make it that would make sulfur the larger of the two elements. And if you compare the neutral to the negative, it gets even bigger here. So between these two elements right here, these two atoms, this is larger. So it goes larger and going to that, and gets larger and going to that. You could definitely say that this would be the bigger of the atoms. All right, these two right here just involve a comparison of a positive and neutral version of the same element. Remember that the more negative something is, the larger it would be. Here, these two elements right here, let's see if we can find those on the periodic table. This one poses a little bit of difficulty because you're comparing, again, things that are both on different periods and on in different groups. All right, so here are the two elements right here, and let's just see what would happen as we, instead of going diagonally, we just make a series of going to the left and then going up. All right, it would get larger as you go to the left, but then it would get larger as you go, smaller as you go up. All right, so if it gets larger and then smaller, all right, we couldn't make a direct comparison. So that would be an inconclusive comparison right there. So in this particular case, we could not tell. Okay, in the next case, we're comparing neutral versions of different elements. All right, so strontium right here, and Ru, I believe that's ruthenium. All right, is right here. So again, we're just making the comparison as you go left on the periodic table. Things get to get larger. So strontium would be the larger of those two atoms. So in this next case, again, you're kind of comparing apples to oranges. So let's first make a direct comparison between the neutral elements here. All right, so if we had to compare a neutral zinc to a neutral iodine, notice that between these two elements, we would not be able to tell, all right, because, again, in going this way to the left, things are getting larger, but then in going up, things are getting smaller. So I can't tell which of these neutral elements would be larger. I would know that the negatively charged iodine would be larger than its neutral version. But the thing is, since I don't know which of these is bigger to begin with, I would not be able to make a conclusion about this. So we'll say you can't tell there. All right. So again, the major things to remember on as far as size is when you're comparing neutral elements, things get larger as you go to the left and as you go down. But if you're comparing the size of ions, the positive version thing is smaller than the neutral, but the negative ion is bigger than the neutral version. So in the next section right here, we're trying to evaluate trends in ionization energy. All right, so remember, ionization energy is the amount of energy required to pull an electron away from a neutral atom. All right, and so in terms of trends, fluorine, neutral fluorine has the highest ionization energy of any of the elements on the periodic table. So remember, we don't include the noble gases here. All right, so you would not be asked about ionization energy of a noble gas. All right, so just comparing all of these on the periodic table. So in these, the ones that are circled should be a fairly easy comparison. All right, the one that I do want to point out here, these two elements right here. All right, notice that one of them is right here and the other one is right here. So remember, the further to the upper right, the higher the ionization energy. And so with the trend being like this, you cannot tell because in going up, things would get higher, but in going to the left, things would get lower. All right, so that's why we just say we can't tell in that particular instance. In the next set, we're using the exact same elements that we did in the set before. The only question is which would have the highest electron affinity. All right, an electron affinity is the amount of energy that an atom releases whenever it accepts an electron. All right, but as far as determining the trend would be the same. Fluorine, neutral fluorine, has the largest electron affinity, and so all of the answers from the previous set would be the same. All right, because it's all it would all just be in relation to what is in the, anything goes up, it gets bigger. Anything goes towards fluorine, it would get bigger. All right, so this one here again, can't tell, and here that would be larger. And so this particular trend right here, electronegativity, this is actually going to be an important trend when we get to covalent bonding. All right, when we have to determine what are called polar bonds. All right, but for now, all you need to realize is that the electronegativity gets higher as you go up and to the right. All right, quick way to remember is that fluorine would be the largest on the periodic table. And so again, these are the same comparisons as the set before, so we can make the same conclusions because in both cases, fluorine is the largest example. All right, this would be can't tell. And between these two, and all right. So in the last part, the question is which would be more reactive. All right, and remember when you're asking which would be more reactive, you can only compare one metal to a different metal or one non-metal to a different non-metal. All right, so as far as the metals, that's this general portion right here. The most reactive metal is going to be in the lower left. All right, so that's going to be cesium. The most reactive non-metal is going to be towards the upper right. All right, and again, notice that this does not include the noble gases. All right, so this would only be so fluorine is the most reactive of the nonmetals. Okay, so notice that between sodium and magnesium, these are both metals. Sodium is further towards that corner right there. Rubidium versus sodium, rubidium is lower, it's more reactive. Sulfur and fluorine, those are both nonmetals. All right, so but comparing sulfur and fluorine, fluorine is obviously the most reactive of those, so it would be most reactive. Between chlorine and bromine, chlorine is higher on the periodic table, and remember those are both nonmetals, so you're going to go more towards the closest to fluorine there. Rubidium is more reactive of those metals right there, and then between these it's fluorine. can skip the questions at the end.